So now discussing some common interview problems on linked lists. So what is the significance of the head pointer in a linked list? The head pointer is essential in a linked list as it points to the first node, providing access to the entire list. If the head is null, then that indicates that the list will be empty. And it's crucial for operations like traversal, searching, insertion, and deletion. Now, what are different types of linked lists? We have single linked list, doubly linked list, and a circular linked list. Now, what are the advantages of a linked list? Firstly, we are able to allocate memory as needed. So there is dynamic memory allocation, unlike arrays that require predefined size, making linked lists more flexible. Then efficient insertion and deletion. Operations like insertion and deletion are faster in linked lists as they do not require shifting elements like in arrays, and they can represent complex data structures. Like they can easily represent structures like graphs or trees, which can be more complex with arrays, and it can be used to implement queues and stacks. They allow efficient implementation of these structures, unlike arrays when resizing can be costly. It can also be used for memory management and caching, and also for garbage collection, where we need to manage memory. They can track objects for garbage collection. Now, what are some disadvantages of a linked list? So, firstly, no random access. Unlike arrays, linked lists do not allow direct access to elements via indexing. So, it would require traversal from the head, which can be slower. Then, more memory overhead. Each node in a linked list requires additional memory for storing the pointers to the next node as well as the data of the current node, which increases the memory consumption as compared to arrays. Then, difficult to debug. So, debugging linked lists can be challenging because of the dynamic memory allocation and pointer manipulation involved, making errors harder to track in linked lists. Also, it is not cache friendly because linked lists do not have contiguous memory storage like arrays, which can lead to poor cache performance and slower access times. Then memory leaks in C or C++. In languages like C and C++, linked lists are prone to memory leaks if nodes are not properly deallocated, as there is no automatic garbage collection like in other languages. Now, what is a cycle or a loop in a single linked list? So, a cycle or a loop is basically when a node in the list points back to a previous node, creating a circular path. This means that if we start traversing the list from any node, we will eventually come back to the same node, forming an infinite loop. Now, what is the time complexity of linked list operations? So, firstly, for insertion at the beginning we have O of n because we already have the head pointer. Then at the end it will be O of n because we will have to traverse the whole list. That is n number of linked list nodes. So that would be O of n. But we can reduce it to O of 1 if we maintain a tail pointer or a reference along with the head. And at a specific position also O of n. Then deletion at the beginning would be O of 1. At the end would be O of n again because we have to traverse the whole list. And at a specific position also O of n in the worst case. Search O of n and traversal as well O of n. Now, how would you compare dynamic arrays versus linked lists? So, dynamic array advantages, firstly, we have fast random access that is in O of 1 time, efficient for larger data sets, and contiguous memory allocation. Its disadvantages are slow insertion and deletion in the middle, that is, it takes O of n time. Fixed size can lead to memory waste or reallocation. Now, linked list advantages, efficient insertion and deletion in the middle O of 1 time, can grow and shrink dynamically, can represent complex data structures. Now, linked list disadvantages, no random access, more memory overhead due to pointers, not cache friendly, and elements can be accessed sequentially only. So dynamic arrays are more efficient for random access and large datasets, while linked lists are more efficient for operations that involve insertion and deletion in the middle. So linked lists are also more flexible and can represent complex data structures. Now, why is a single linked list inefficient for reverse traversal, and how does a doubly linked list solve this? So in a single linked list, each node points only to its next node. So reverse traversal is impossible because we don't have any pointer to the next to the previous node without starting from the head and moving forward until the target node is found again. But in case of a doubly linked list, it stores both the next and the previous pointers, allowing efficient forward as well as reverse or backward traversal in O of 1 time per step. Now, why is merge sort better than quick sort in a single linked list? So the answer is merge sort is better than quick sort because it does not require random access to elements in a single linked list. Quicksort relies on indexing, which is inefficient for linked lists, while merge sort works by dividing the list and merging it, making it more suitable for linked lists. Now, merge sort also guarantees a stable O of n log n time complexity, even for linked lists, whereas quicksort's performance can degrade to O of n square in the worst case. So, since quicksort relies on indexing, which is inefficient for linked lists, because we don't have any index or specific pointers to point at a particular index, but merge sort divides by dividing the list and merging it, and it does not believe in indexing, right? So that is why it guarantees a stable O of n log n time complexity even for linked lists, but quicksort's performance can degrade to O of n square in worst case. Now, what are the applications of doubly linked list? Browser history. Doubly linked lists are used in browsers to track the history of visited pages, enabling users to go forward or backward through the list of pages with efficient navigation. Then undo operations in applications like word processors or image editors, where we have to go back like perform the control Z operation. Doubly linked lists maintain a history of the actions that we have taken, like text changes or editing steps or removal of an element, allowing users to easily undo or redo operations in either directions. So control Z and control Y. Now, what are the applications of a circular linked list? So we have round robin scheduling, a scheduling algorithm used in multitasking operating systems where each process is assigned a fixed time slice to execute in a cyclic order. Then we have circular buffers, a data structure used to manage data in a fixed size buffer where the buffer wraps around when it reaches the end, often used in streaming or real-time data applications. Now, what is the advantage of using a circular doubly linked list over a regular doubly linked list? So, a circular doubly linked list has the advantage of continuous traversal from the last node back to the head and vice versa, since it is circular. This allows for easier and more efficient operations in circular data structures like implementing round robin scheduler for uh, any purpose, or a playlist where you need to wrap around to the beginning after reaching the end. Now, some practice problems I'll be covering in the next video, but let us first go through the algorithm. Sorry, let me show you. First, let me show you single linked list. Right. So it is a linear data structure in which the elements are not stored in contiguous memory locations, and each element is connected only to its next element using a pointer. Right. So then we have some easy problems on linked list and hard problems. You can go through these, and I'll be covering each one in depth in the coming videos. So stay tuned.